Here I have a side, and how long is this side right here? That is the square root of 5. And this may seem like a real basic review for some of you. And this side is also square root of 5. And inside the square, how big is that square?
5.
This is 5. Prove to me that this is 5. How do I know? If I only had this part right here, how would I know that that square is 5?
Draw a bigger square around it.
Okay, I could draw a bigger square around it, but just with what's on the board, is there a way that I can prove it, Braden? So you're saying since this is the square root of 5 and that's the square root of 5, this has to be 5. Okay, Krista? So right here, you would do the same thing again on this side right here and right here. And connecting these, you could do the Pythagorean theorem again and make sure this is the square root of 5, that's the square root of 5, this is going to give me 5. Okay. All right. Here I have two sides. What makes a square? 4 equal sides, but also what? There's something else. Okay, it has to be a right angle. Okay, so I've got 4 equal sides with a right angle. And so this side is the same as that side. Does everybody agree that these two sides are the same? All right, so with this, if I have the square root of 5 right here and the square root of 5 right here, inside, since I have two sides that are the same, this is going to be 5. The square root of 5 times the square root of 5 gives me a square because the sides are the same. Pretty simple, right? If the sides are the same, I have a square. What if the sides are not the same? What if I have this side right here? If I have that side, do I still have a square? Let's go down and see what happens. That right there, how long is that? Square root of 5. But what if I extend it to right there? How long is that whole segment now? Is it the square root of 10? Okay, I've got 2 square roots of 5, 2 square roots of 5, or what else? How do you know it's the square root of 20?
Above it.
Okay, so you're going from here to here, and that is 2, so the square is 4. And then I've got this side, which is how long? 4, so the square is 16. So this side length is how long?
Square root of 20.
Okay, so this 2 square roots of 5 is the same as the square root of 20. So I have the square root of 2 square roots of 5 is the same as the square root of 20. But when I multiplied before, I had this right here, and this gave me a square. How big was this square? It's 5. But now I don't have a square anymore. What do I have instead? I have a rectangle. How big is my rectangle? If this is the square root of 5, and that's the square root of 5, how big is this? 5. If this is the square root of 5, and this is the square root of 5, how big is this? 5. How big is my rectangle? It's 10. I'm going to do the same section again. So if I have the square root of 5 right here, and I have that same side length right here, this time that's the square root of 20, and this is the square root of 5. Up here I had the square root of 5 times the square root of 5 is 5. This is another square root of 5, so I have square root of 5 times the square root of 5 is 5. And that gives me 10 is the area of my rectangle. Down here, I have the square root of 5 times square root of 20. Square root of 5 times the square root of 20 is square root of 100. Pray tell, what is the square root of 100? It's 10. Still equals 10. So we can see this two different ways. Give me a number.
2, 6, 9, 8.
Give me a letter.
L.
Give me a number.
3.
Okay. Now, how would I set up an array like this? And you guys did this at the beginning of the year. Remember when we had you drawing pictures of the distributive property? You've got two things that are getting multiplied here. 2 and a plus 3. What does the first number tell you? How many there are? There are 2 of them. 1, 2. 2 of them. Now, what is it being multiplied by? A plus 3. How long is A? We don't know. So let's draw it that long, and we'll say that's A. Now, the 3 parts that are coming, they're going to be the same size as these. So it's going to be 1, 2, 3. And we are now going to finish our array. Now we know what the distributive property, so now here I have A, and here I have 1, 2, 3 pieces. That's A plus 3. So if I take 1 times A, how big is this rectangle right here? Well, we kind of don't know, but we have a name for it. What do we call it? A. How big is this rectangle? 1 times 1 is, 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 1 times 1 is. So, looking at my answer, what is my total answer?
2A
Plus 6. Or, if we do the distributive property, we get 2A plus 6.